Hello, this is Dr. Jack Jackson. In this video, we're going to be talking about how to compute some probabilities that relate to poker hands. So this is a good example of how we can use some combinatorics. And actually working out the different probabilities in this set of the different possible poker hands being dealt out on a single deal, which is the probability we're going to be computing. This actually works out. Some of these are pretty easy to do. Some are quite a bit harder to do. But by the time you get through working through these, you have a pretty good understanding of how combinatoric type arguments work and how we can use combinations put together to figure out different probabilities. So the basic setup in a game of poker, a basic hand is made up of 5 cards. And so we're going to just consider the simplified game of poker where you just shuffle up the deck, completely randomize it, and you deal out 5 cards, and that's it. And so there are various types of poker hands, including things like a straight, a flush, 4 of a kind, 3 of a kind, full house, and so forth. So what's the probability of being dealt to each of these types of hands on a single deal? Now, of course, poker, that's not usually what happens. Usually you turn some cards back in, or there's some shared cards, or some, depending on the variation of poker you play. But it's all based on this basic setup here. And the probabilities that we're going to be computing here then are used to determine the relative power of the different hands, and thus which hand beats which other one. So it turns out here we can use our counting techniques to determine these probabilities. And some of these are easy and some of them are pretty difficult. But let's take a look at these. So first of all, how many poker hands are there? Well, there were 52 cards that we're choosing from, and we're choosing 5 of them. It doesn't matter what order they go in our hand. We can reorder them in our hand once we get them. So it's 52 choose 5, which is 2,598,960. And that's going to be the denominator in all of the poker hand probability calculations will be this number here. So almost 2.6 million poker hands. All right, so the first one we're going to look at is a 4 of a kind. So 4 of a kind is a hand where 4 of the 5 cards have the same rank value or pip value. For example, 4 jacks, or as pictured here, 4 aces. And the other card can be anything else. Obviously, you can't have a 5 of a kind, at least not without some kind of wild cards being used. And so how can we count this? Well, there are 13 ways of picking the rank. So there's 13. That's 13 choose 1. 13 ranks, choose one of them, which is 13. And once you pick that, then that determines 4 of the cards. And then the 5th card could be anything. So once you've picked that card, you've eliminated 4 of the cards, 4 of the 52. So that leaves 48 other cards. And you could pick any one of those. So it's 48 choose 1. Or in other words, just 13 times 48 is 624 for the numerator. And the denominator, as we've already said, is 2,598,960. That reduces in a fraction form to 1 over 4,165 is the exact probability. Or in percent form, rounded off, that's about 0.0240%. And I've got a TI Inspire screen showing me showing this worked out over here. And then there's a picture of an example right there. Okay, so that's a 4 of a kind. If you have 2 people that get a 4 of a kind, then whichever one is the 4 of a kind's a higher value will win. So this one right here would win because aces are generally considered high. So that would beat aces would beat kings, kings would beat queens, and so forth. Now the next one we want to look at is something called the full house. A full house is 3 of one rank and 2 of a different rank. So if 2 players have a full house, the one with the higher value on the 3 of a kind wins. So 3 kings and 2 tens is going to beat 3 tens and 2 kings. Okay, but how many different full houses are there? Well, first we have to choose the rank for the 3 of a kind. So there are 13 ways of selecting that. 13 choose 1. There's 13 ways of selecting the rank of the 3 of a kind. Now the 2 of a kind, well, wait a minute. Before we go on further, Once you've picked the rank, now let's say we picked kings, then there are actually 4 different ways of picking basically 4 different ways of picking the king that's not there, if you want to think of it that way. So that would be 4 choose 1 or 4 choose 3. Either way, that's 4 ways. So far we have 13 times 4. So 13 ranks, choose one of them for the 3 of a kind. The 4 cards in that rank, we're going to choose 3 of them be in our hands. So that's 13 times 4. Now, then we have to choose our second rank. We've already chosen one of the ranks, so now we're down to from 13 down to 12, and we're choosing one of those. So that's 12 here. And of the 4 cards in that rank, we're going to choose 2 of them. So at 4 choose 2 is 6. So it is, you can see it here, worked out. So it's 13 times 4 times 12 times 6 over, again, our denominator that all these have to begin with, 2,598,960. So there are actually 3,744 different full houses. And here it is as a probability. Reduces to 6 over 4,165, or about 0.0144%. And again, here's an example with what we call this kings over tens. All right, the next kind we'll look at is 3 of a kind that's not a full house or a 4 of a kind. So it's strictly just 3 of a kind. The other 2 cards don't match either the 3 of a kind or each other. If there's 2 players with the 3 of a kind, then whichever one has the higher value is going to win within the 3 of a kind. So now, how many ways can we do that? Well, first we have to pick which one is going to be a 3 of a kind. We're the 13 different ranks, and we're going to choose one of them. So that's 13 choose 1, or 13. Again, the 4 cards in that rank, we're going to choose 3 of them. So that's 4 choose 3, or 4 ways we can do that. Now, since it's not a full house of a 4 kind, we have to choose 2 additional ranks. And so that's 12 choose 2 equals 66 different ways of choosing the other 2 ranks. And once you choose those ranks, there are 4 cards. We're choosing 1 of each of those ranks. Okay, so here we chose the jacks first. It could have been any one of the 13 ranks there. 4 choices of which 3 we pick in that rank. 66 other different choices for the two ranks here with 4 cards in each one. Multiply all the numerators there. That's 54,912 different 3 of a kinds. Again, not being a full house or a 4 of a kind. That fraction reduces to 88 over 4,165, or now about 2.1128%. All right. Actually, the highest hand, the least probable hand, is something called a straight flush. So it's both a straight and a flush. So a straight is a 5 cards in sequence, numerical order, going up 1 at a time, and a flush is all the same suit. So, for example, like the one I pictured here is a straight flush, 5, 6, 7, 8, 9, all of spades. Okay. So how many ways can we do that? Now remember, a jack is counted kind of like 11, a queen is a 12, and a king is a 13. And depending on the game, usually an ace can be counted as either high, essentially a 14, or low, essentially a 1. So the highest card cannot be a 2, 3, 4, or 4, or if aces are not allowed to be low, it couldn't be a 5 either. So the lowest card, so think about choosing your lowest card. Well, so that leaves out, let's see, that's 3 rank values times 4 suits is 12 cards that can't be the lowest card. Subtract that from 52, that leaves 40 choices for the lowest card. Once the lowest card is picked, everything else is automatically locked in. So there are 40 straight flushes. Okay, and that reduces to 1 over 64,974, or about 0.0015%. The highest, if you get 2 straight flushes, the one where the highest card of all here in the straight flush is the biggest is going to win. So one that goes from 5 to 9 is going to beat one that goes from, say, 3 to 7. So the one that's unbeatable is the one that's Jack, Queen, King, 10, Jack, Queen, King, Ace. That's called a royal flush. So 2 royal flushes would split the pot. Okay, but a royal flush is unbeatable. Now a flush that's not a straight flush, we'll just call it a flush. So that's 5 cards of the same suit, which are not a flush, a straight flush. And so there, you have to first pick the suit. So there are 4 ways of doing that. And then once you've picked that, then you pick any 5 cards in that suit. So there's 13 to choose from. So that's 13 choose 5. But we already figured out the 40 that are straight flushes. So we're going to subtract that off. So there'll be 4 times 1,287 sets of cards, all the same suit, but we subtract the 40 that are straight flushes. That leaves 5,108 flushes that are not straight flushes. And so this is your probability here, reduces to 1,277 over 649,740, or about 0.1965%. Now remember, all these probabilities are just being dealt in one, just being dealt out 5 cards, and that's what you have. All right, well, what about a straight? Is a straight better or worse than a flush? Okay, well, again, we've already talked about what a straight is, but we want to eliminate a straight flush. So, again, like we said earlier, there are 40 choices of what could be the lowest card. But once you pick that, there are 4 choices for the next card up, 4 for the next, 4 for the next, and 4 for the next. That would be all of the straights. However, that would include the straight flushes, so we have to subtract the 40 straight flushes from that. So 10,240 total straights, take away 40 that are straight flushes, that leaves 10,200 straights, which are not straight flushes. And so there's the probability right there. Reduces to 5 over 1,274, or about 0.3925%. 2 pair is a hand that's 2 cards of the same rank, a pair, and then another pair of the same rank, but not the same rank as the first. Same rank as each other, but not the first. Like here, I've got a pair of 10s and a pair of 6s. If 2 players have a tie, then whichever one has the highest pair wins. So a pair of 10s and 6s would lose to, say, a pair of queens and pair of 5s. Okay, because you just go by the highest one. So if there's a tie there, then it would go to the second pair. So for example, if the other person had also had 2 10s but then had 2 3s, this hand right here would win because the 6s would beat the 3s. If they both were 10s and 6s, like this, then you go to the rank, which one is the bigger rank on the leftover card. So you sort of break ties like that. Okay, so how many ways can you make 2 pair? Well, let's see. So we want to choose the 2 ranks. Well, there are 13 ranks to choose from. We're going to choose 2 of them. That's 13 choose 2 is 78 different ways of picking the 2 numbers for the 2 pair. Once you pick that, once you pick the 2, for the first one there are 4 cards, and we're going to choose 2 of them for that pair. So that's 4 choose 2 or 6 ways to do that. Similarly, 4 choose 2 or 6 ways for the other one. Then that leaves the final card. Well, we've eliminated, it can't be, like in this case, it couldn't, the last card couldn't be a 10 or a 6 because then you'd get a full house, which we don't want the 2 pair to include a full house. So what does that leave? Well, you've eliminated those cards. How many are left? Well, you've eliminated actually 8 cards. Okay. So there are 52 minus 8 is 44. So there's 44 left, and you could choose any one of those. So times 44 here. So 78 times 6 times 6 times 44 is 123,522, and that is the number of different 2 pair hands. So that probability then reduces to 198 over 4,165, or about 4.7539%. All right, how about one pair? Okay, so one pair, or two of a kind, is a hand that contains two cards of the same rank, a pair, and the rest of the cards have different rank than this, and they're all different ranks, so everything's all different from each other. So if there's two cards, if the highest hand is a pair, and there's two people that have a pair, the one with the highest ranking pair wins. So this two aces, for example, would be a hand that just had two kings. If two of them have two aces, you go to the highest ranking card of what's left. Okay, so what's the probability of being dealt two of a kind, a pair? And we see here. So first of all, you have to pick the rank for the pair. So there's 13 ways of choosing that. 13 choose 1, so that's 13 ways. Then you have to pick the two cards in that rank. There are 4 cards to choose from, and you're choosing 2 of them, so it's 4 choose 2 equals 6 ways of doing that. Now, you have to pick the next 3 ranks. They all have to be different than each other and different than the one that's here. So that leaves 12 ranks to choose from here, but we're going to choose those ranks all to be different. So that would be 12 choose 3, which is 220 for those 3 ranks. And then once those are picked, you can pick 4 cards in each one, 4 choices in each one to pick 1 card each, 4 choose 1 or 4 each. So it's 13 times 6 times 220 times 4 times 4 times 4 is 1,098,240, and that put it over the denominator, which is how many hands there are all together, and we get that reduces to 352 over 833, or for the first time we get to a hand that's actually pretty likely to be dealt right off the bat, which is a pair, which is 42.257%. And of course, the most probable hand is none of the above. Sometimes it's just called a high card hand. In other words, nothing special. And it's one that does not fit any of the special hands above. So if it's if the best thing is a high card hand, then the one with the highest ranking card wins. And so we're just going to do 1 minus the probability of getting all the hands above. And actually, I counted up. I added all those up. I've got them in a table on the next slide. Well, I'll just show you. And here are the different number of hands. If I add up all these that we've computed before and subtract from the total number of hands, that leaves 1,302,540. And of course, do that over this here, and that will be a probability of just a high card hand. That reduces to 1,277 over 2,548, or about 50%, just a little over 50% there. So when you put them in order here, from the least probable to the most probable, you get the rank or power of the hands. So the highest hand is a straight flush. Of course, the highest straight flush would be a royal flush. That's royal flushes are included in this. Some people will split royal flushes out from straight flushes. If you do that, of course, there are 4 royal flushes and then 36 straight flushes that are not royal flushes. All 40 of those are in there together. There are 624 different 4 of a kinds, 3,744 different full houses, 5,108 flushes, 10,200 different straights, 54,912 different 3 of a kinds. Then goes to 2 pair, and just a high card. And so that rank then is the probability order of increasing probability. And so the one that's the lowest probability is the highest hand, and that hand wins. So you see that a straight flush beats everything else. 4 of a kind is next higher. Full house beats a flush beats a straight. All of those beat a 3 of a kind. 3 of a kind beats 2 pair, which beats a pair. And of course the worst is when you don't have any of the above. Now again, remember that the ranking of these poker hands is from that, and these ranks are only for being these probabilities, at least, not the ranks, but the probabilities are just for being dealt this as a 5-card hand just right off the bat. Now, and actually, different kinds of poker, for example, there's different there's more complicated than this. In stud poker, for example, you're allowed to turn some of your cards back and replace them with new cards, usually a couple of times. In other versions, there may be some cards out in the middle that are common cards that are used, that you choose those to put with some of the cards in your hand. But ultimately, when it comes down to it, you build your best 5-card hand in this way. And of course, that makes the probabilities in those situations will change somewhat. In fact, you've got a better chance of getting something good if you're allowed to keep trying. But still the ranking still goes back to these probabilities right here, which again are the probabilities of just being dealt that kind of a hand straight off the bat. So I think this is a good practice in doing some combinatoric type arguments. We use these different combinations here to figure out these probabilities.